Hello students, let me ask you one question. What is the graphical or geometrical interpretation of the roots or zeros of the equation fx is equal to 0? You must have studied this in 10th grade in the chapter Polynomial in NCERT book. What is that? The roots or zeros of the equation fx is equal to 0 are actually the values of x where the graph of the corresponding function y is equal to fx cuts the x-axis. So the graph of the function y is equal to fx is an important tool in the study of roots of the equation. This graph also helps in studying the inequalities involving function y is equal to fx. In this chapter, we will focus on quadratic equation and the graph of the corresponding quadratic function. Let's start with the most elementary quadratic function y is equal to x square. This is also called a square function. Let's draw the graph of this function. Now the least value of x square is 0 when the value of x is 0. So here the least value of y is also 0. So on the graph of the function we have a point 0, 0. Now if you take x is equal to plus minus 1, the value of y is 1. If x is plus minus 2, the value of y is 4. If you join all these points, we have graph of the function like this. This type of shape is called a parabolic shape. In fact, the graph of quadratic function is always a parabola. Here 0, 0, which is the lowest point on the graph, is called the vertex of the parabola. Also, the graph is symmetrical about y-axis. Here y-axis is called axis of the parabola. Axis of the parabola divides parabola graph into two equal parts. Also, axis of the parabola is normal to parabola at vertex. Consider quadratic function y is equal to x square plus 2. We can put this function as y minus 2 is equal to x minus 0 square. The least value of x square is 0 when the value of x is 0. So here the least value of y is 2. So on the graph of the function we have point 0, 2. This is the lowest point on the graph because least value of y is 2. If you take any other value of x, the value of y is more than 2. So from this point, graph moves upward like this. Here 0, 2 is the vertex of the parabola and graph is symmetrical about y-axis. So in this case also, axis of the parabola is y-axis. Consider more general quadratic function y is equal to x square minus 2x plus 3. With little simplification, we can put this function as y is equal to x minus 1 square plus 2. Now, the least value of x minus 1 square is 0 when the value of x is 1. So, in this case, the least value of y is 2. So, on the graph of the function, we have point 1, 2. So here we have a coordinate axis and we put the point 1, 2, which is the lowest point on the graph. Now if you take any value of x other than 1, the value of y will be more than 2. So now graph moves upward from this point like this. Here 1, 2 is vertex of the parabola. We can see that the graph is symmetrical about line x is equal to 1. So x is equal to 1 is axis of the parabola. Now let's see one quadratic function in which the coefficient of x square is negative, and let's see how to draw the graph of such type of quadratic functions. In that case, consider quadratic function y is equal to minus x square minus 4x plus 1. You can put this function as y is equal to 5 minus x plus 2 square. Now the least value of x plus 2 square, which is perfect square, is 0. This least value occurs when the value of x is minus 2. Now when x plus 2 square is least, we can say the value of y is maximum. Why? Because we are subtracting x plus 2 square, which is variable, from constant value 5. So when x plus 2 square is least, this difference is maximum. So we have y is equal to 5 when x is equal to minus 2. So on the graph of the function we have point minus 2 comma 5. This point is the highest point on the graph because y is equal to 5 is the maximum value of y. So from this point graph moves downward. So we have graph like this. Here vertex is minus 2 comma 5 and graph is symmetrical about line x is equal to minus 2. So x is equal to minus 2 is the axis of the parabola. So now we can draw the graph of any quadratic function. So what we learned from the discussion so far? You consider general quadratic function y is equal to ax square plus bx plus c. Here the graph of the function is parabola. Now when a is positive, which is coefficient of x square, the graph is concave upward, and if a is negative, the graph is concave downward. Also, the graph of quadratic function always has a lowest point or highest point, or we can say the function has either a point of minima or point of maxima. Also, the graph of the function is symmetrical about vertical line through the vertex. This line is normal to the parabola at vertex. This is called axis of the parabola. Also we understand that we can put any quadratic function in the form y minus k is equal to a times x minus h square, where h comma k is the vertex of the parabola. For this quadratic function y is equal to ax square plus bx plus c can be put in this form: y plus d upon 4a is equal to a times x plus b by 2a whole square. Here d is a discriminant of quadratic function or corresponding equation. We know the value of d, which is b square minus 4ac. So in this case, vertex of the parabola is minus b by 2a minus d by 4a. From the discussion so far, we understood how to draw the graph of any quadratic function. Let's extend this study. Consider general quadratic equation ax square plus bx plus c is equal to 0. So we have corresponding function y is equal to fx is equal to this. We want to draw the graph of this function. Let's start with the value of a. If a is positive, the graph is concave upward. Now with respect to the points of intersection with x-axis of graph y is equal to fx, we have this three possibilities. We have this first possibility in which graph is intersecting x-axis at two distinct points, alpha and beta. In fact, coordinates of these points are alpha comma 0 and beta comma 0, but here I am putting alpha beta. Now these two values of x makes fx is equal to 0. That means alpha and beta are roots of the equation ax square plus bx plus c is equal to 0. When quadratic equation has two distinct roots, the value of discriminant is positive. So for this graph, d is greater than 0. In second possibility, we have a graph touching x-axis. Here we can say roots alpha and beta are coincident, or we can say roots are equal. And when roots are equal, discriminant of quadratic equation is 0. So in this case, d is equal to 0. Now we have a third possibility in which graph is like this. Here graph always lies above x-axis. That means there is no real value of x, which makes fx is equal to 0. That means roots of quadratic equation ax square plus bx plus c is equal to 0 are non-real. So in this case, d is less than 0. Now in this graph, if you take any point on the graph, the ordinate of that point is positive. That means y is always positive. Y is positive. That means ax square plus bx plus c is greater than 0 for all x belongs to R. If you take any value of x, this quadratic function is always positive. In second figure, graph is touching x-axis. Here, the value of y is either 0 at the point of contact or positive. So in this case, we can say y or ax square plus bx plus c is greater than or equal to 0 for all x belongs to R. In the first figure, where the graph is intersecting x-axis at two distinct points, we can see that between alpha and beta, when the value of x lies between alpha and beta, the value of y is negative. That means the value of quadratic function is negative. And when x lies outside alpha and beta, the value of quadratic function is positive. Now consider a less than 0. In this case, the graph is concave downward. With respect to the points of intersection with x-axis of this graph, we have again three possibilities. So here we have graphs for three possibilities. In first figure, graph is intersecting x-axis at two distinct points, where the value of x is alpha and beta, which are roots of the equation ax square plus bx plus c is equal to 0. Obviously in this case, discriminant is greater than 0. In second figure, where graph is touching x-axis, the roots are coincident, so discriminant is equal to 0. In third figure, graph is not intersecting x-axis. That means roots of the quadratic equation are imaginary. So in this case, discriminant is less than 0. In third graph, where d is less than 0, If you take any point on the graph, the value of y is negative. That means here ax square plus bx plus c is less than 0 for all x belongs to R. This graph is always lying below x-axis where y is negative. In second figure, where graph is touching x-axis, ax square plus bx plus c is less than or equal to 0 for all x belongs to R. And in first figure, between alpha and beta, when the value of x lies between alpha and beta, the value of quadratic function is positive, and when x lies outside alpha and beta, the value of quadratic function is negative. You are not supposed to remember all these conditions. When these conditions are required, you just plot the graph and write the observations. Now consider ax square plus bx plus c greater than 0 for all x belongs to R. For this quadratic inequality, what is the possible graph of quadratic function y is equal to ax square plus bx plus c? What is possible graph? We have this graph. In this graph, a is greater than 0 because graph is concave upward, and d is less than 0 because graph is not intersecting x-axis. So a greater than 0 and d less than 0, these are two conditions for any quadratic function to be positive for all x belongs to R. Similarly, if we have ax square plus bx plus c less than 0 for all x belongs to R, the possible graph is this one. Here a is less than 0 because graph is concave downward, and d is less than 0. Now consider ax square plus bx plus c greater than or equal to 0 for all x belongs to R. You draw the graph of you draw the possible graph for this situation. Okay. Now I doubt you may have drawn only this graph, where graph is touching x-axis, because in this case ax square plus bx plus c is greater than or equal to 0 for all x belongs to R. But don't you think this graph is also one of the possible graphs? Here, so what? Quadratic function is not 0, it is always positive. So for this inequality, we have these two possible graphs. In first graph, d is equal to 0, and in second graph, d is less than 0. So we have conditions a greater than 0 and d less than or equal to 0. Similarly, if ax square plus bx plus c is less than or equal to 0 for all x belongs to R, now you draw the possible graphs. This time you must be correct. We have these two possible graphs. Graph is concave downward. In first graph, graph is touching x-axis, and in second graph it is lying below x-axis. So we have d less than or equal to 0 again. So for this quadratic inequality, we have conditions a less than 0 and d less than or equal to 0. We will see how to use these conditions in solving some inequality based problems. Let's try one question which is based on analysis of the graph of quadratic function. Here we are given the graph of quadratic function y is equal to fx is equal to ax square plus bx plus c. From this given graph, we have to identify the sign of values of a, b and c. We have to check whether a is positive or negative. Similarly, b and c. Let's start with a. How you can identify the sign of a? A is coefficient of x square. Graph is concave upward, so a is greater than 0. Further, this point where graph is intersecting y-axis. For this point, the value of x is 0, and when x is 0, from the function f of 0 is equal to c. So the coordinates of this point are 0, c, where c is obviously less than 0 because this point is lying below x-axis. So y is negative and hence c is negative. Now the value of b. How you can identify this value? For that, our helping hand is vertex. The coordinates of vertex are minus b upon 2a minus d upon 4a. Now vertex is lying to the left of y-axis. So we can say the abscissa of the vertex minus b upon 2a is less than 0. But here a is already positive. So the value of b is also positive. So we got the sign of values of a, b and c from the analysis which we have discussed so far. Let's try one more question on the analysis of the graph. We have this question, if ax square plus bx plus c is equal to 0 has imaginary roots and a plus c is less than b, then prove that 4a plus c less than 2b. Now we have this quadratic equation. The corresponding quadratic function is fx is equal to this. Now it is given that roots are imaginary. So what are the possible graphs for this quadratic function? We don't have knowledge about a. A may be positive or may be negative. So we have this possible graphs. In first graph, a is positive. So it is concave upward. It is not intersecting x-axis because d is less than 0. In second graph, a is negative. So it is concave downward and it is always lying below x-axis. That means this quadratic function is either always positive or always negative. Now let's see how this condition helps. A plus c less than b. Now we can put this condition like this. Take b to the left. So we have a minus b plus c less than 0. Now look at fx and then this expression a minus b plus c. Do you get any idea? We can get this expression a minus b plus c when we put x is equal to minus 1 in function fx. In fact, a minus b plus c is f of minus 1. So we have f of minus 1 less than 0. In which graph this is possible? Obviously in the second graph, because in first graph fx is always positive. So f of minus 1 is less than 0 is possible only in second graph. You can see how we are eliminating graphs from the given conditions. We have 6 possible graphs for quadratic function. When a is positive, we have 3 graphs. When a is negative, we have again 3 graphs. Here it is given the roots are imaginary. So we eliminated 4 graphs. We had only 2 graphs. Now from f of minus 1 less than 0, we get this only possible graph. Now for this graph, fx is less than 0 for all x belongs to R. Now we have to prove that 4a plus c less than 2b. We can put this way. 4a minus 2b plus c less than 0. This is f of minus 2 less than 0, and which is obvious because graph is concave downward and always lying below x-axis. So f of minus 2 is also negative. Let's try one question based on quadratic inequality. The question is if x square plus 2ax plus a less than 0 for all x belongs to 1 to 2, then find the values of a. We will solve this question using graphical concepts. So for that, you consider this quadratic function fx is equal to x square plus 2ax plus a. The graph is concave upward. Now we have to make this quadratic function to be negative for all x belongs to 1 to 2. That means graph must intersect x-axis. So the possible graph of the function is like this. The graph is concave upward and intersecting x-axis at 2 distinct points. Now again focus on the question. This function is negative for all x belongs to 1 to 2. So here the location of 1 and 2 on x-axis is important. Let me put 1 and 2 here. Now tell me, is this possible? Because we want function to be negative for all x belongs to 1 to 2. In that case, are these possible locations for 1 and 2? You can check between 1 and alpha, the value of function is positive. Between alpha and beta, the value of function is negative, and between beta and 2, the value of function is again positive. So obviously these locations are not possible because we want quadratic function to be negative for all x belongs to 1 to 2. But here for some values of x function is positive and for some values of x function is negative. So what we can do, we shift 1 and 2 towards roots. Let's put 1 and 2 on the roots. That means alpha is equal to 1 and beta is equal to 2. Again the question is this possible? If we put 1 and 2 on the roots for this values of x, fx is equal to 0. But we want fx to be negative only. So we can't put 1 and 2 on the roots. So 1 and 2 comes between roots like this. How you can ensure that 1 and 2 are lying here only between roots alpha and beta? Now for x is equal to 1, for this case the value of function is negative. That means f of 1 is less than 0. Similarly, we have f of 2 less than 0. From this we get 1 plus 2a plus a less than 0, or a less than minus 1 upon 3. And for this we have 4 plus 4a plus a less than 0. That means a is less than minus 4 upon 5. We want both these conditions. So we will take intersection of these two values, and the common values are a belongs to minus infinity to minus 4 upon 5. Let's try one question asked in JEE exam. The question is if ABC be real and if ax square plus bx plus c is equal to 0 has two real roots alpha and beta, where alpha is less than minus 1 and beta is greater than 1, then prove that 1 plus c upon a plus modulus of b upon a is less than 0. So we have this quadratic equation having roots alpha and beta. We have to prove this inequality. Now from the terms in the inequality c upon a and b upon a, from this I should divide given quadratic equation by a. So I have quadratic equation x square plus b upon ax plus c upon a is equal to 0. I modified the equation from the condition which I have to prove. So the corresponding quadratic function is this. Let's draw the graph of this function. Again, start with the coefficient of x square. So graph is concave upward. Also the equation has roots alpha and beta. So graph must intersect x-axis at two distinct points, alpha and beta. So here we have graph, alpha and beta are roots. Now alpha is less than minus 1 and beta is greater than 1. So where you locate minus 1 and 1 on x-axis? Where you locate? Obviously minus 1 must be here somewhere between alpha and 0, and 1 here between 0 and beta. Now we want roots to be like this: alpha less than minus 1, beta more than 1, and we have placed minus 1 and 1 between roots. But for that some conditions are required. Automatically minus 1 and 1 do not fall between roots. When this occurs? When f of minus 1 is less than 0. You can see f of minus 1 is negative. Similarly, f of 1 is less than 0. So we have 1 minus b upon a plus c upon a less than 0, and 1 plus b upon a plus c upon a less than 0. Okay. Now if we combine these two conditions, we get one condition: 1 plus modulus of b upon a plus c upon a less than 0. So you can see how these graphs are useful to solve this type of questions. In fact, the graphical analysis and graphical study make these problems too simple, because everything is visible when you plot the graph. Let's try one more JEE question. Here is the question. The question is the roots of this equation are unequal. for all real values of b, then we have to find the values of a. Since the roots are unequal, so we have a discriminant greater than 0. But for all real values of b, here this statement is very important. Okay. Now discriminant of the equation is a minus b square minus 4 times 1 minus a minus b. This is greater than 0 for all b belongs to R. Now this inequality is true for all b belongs to R. That means we must consider quadratic inequality in b. So we have this inequality b square plus collect the coefficient of b. So we have 4 minus 2a multiplied by b plus a square plus 4a minus 4 greater than 0 for all b belongs to R. Now here we have quadratic inequality which is positive for all b belongs to R. What are the conditions for this? We must have coefficient of b square positive. Here it is 1 which is positive. So this condition is already fulfilled. Further we have a discriminant of this quadratic function in b must be less than 0. So we have 4 minus 2a whole square minus 4 times a square plus 4a minus 4 less than 0. Here we have discriminant of discriminant. Now let's solve this. From the first perfect square take out 2 common, so we have 4 outside. Now from this we can cancel out 4. Okay. Now you expand this 2 brackets. We have some terms cancel out, so we are left with minus 8a plus 8 less than 0. And by this we get a greater than 1.